Hi folks, Dave Swanson here. It's December 27th, 2024. Today I'm just going to show you kind of the results of what I'm kind of calling a snapshot of the Carolina Bays. A snapshot's kind of been something I've thought about doing for a while. I've been learning some GIS and some other things, so I kind of put together my own little study. I wanted to kind of take a more granular look at uh, somewhere where there's Carolina Bays. Specifically maybe look at soil types, look at elevations, look at a variety of factors, and then see how the bays are distributed, and see if there's any correlations between soil types and uh, geometry of the bays, things like that. So I chose North Carolina because it is has the state itself did a really good job with available resources online for mapping and GIS type work. So I'll kind of try to go through it pretty quick so we don't really waste a lot of time, or I don't take a lot of time. We'll be using basically this map a little bit later to look at soil types and the counts of bays in there, and specifically, we're going to see a lot of density up in this area and a little bit up here, and then kind of less distributed here. So uh, we're going to see kind of the second part of this presentation relating the density of bays to the soils. First, we're going to kind of look at elevations. So this is the east coast of North Carolina. This is a digital terrain map. It's actually made up from NASA LiDAR data that I downloaded. Yeah, it's kind of weird colors. I'm having a problem with that because this mapping application is really suited for more zoomed in types of views. And there's just not a lot of terrain difference here in the state. So quickly we'll look. We see a lot of yellow. The yellows are kind of the purple is sea level. The yellows are kind of the intermediary levels, 50 feet to 80 feet. The blues are 80 to 100. We start to get into kind of a light purple, which are 100 to 150. Then this little blue streak that we see are darker blues, a couple 100 feet. The greens are 250, and we work up to 300, and there's even a couple 500-600 footers in here, part of the terrain. This purple line is the fall line, so we've everything on the east side of this is considered the coastal plain. We'll see that from that fall line here, we're about at 200 feet to sea level through that distance, and over in this area we're can be up to 500 feet to sea level. So we have some higher terrain in here. It's flatter in these areas. So these are the locations of all 14,309 Carolina bays in North Carolina. And we will notice, as we pointed out, we did have this one kind of large soil group in this area. We'll see it on a map shortly. And then we also have a higher terrain in this area, and then the lower terrain. So we do see more density here. We see quite a good density right along the coast, a couple of these barrier islands and such. So that's 14,309 bays. I'm going to break it out into individual meters, and because that's how I did in the table that we're looking at, and I just want to kind of show what that looks like. So the red dots are the Carolina bays that are located 70 meters and up in sea level elevation. There's 1,432 of those, and that's about 10% of all the bays in North Carolina. The white bays are bays located 60 to 69.99 meters above sea level. There's 1,688 of those, and that's about 11.8% of all the bays in North Carolina. The yellow markers are all the bays located 50 to 59.99 meters above sea level, and there are 2,591 of those, and that's about 18.11% of all the bays. The green bays are located 40 to 49.99 meters above sea level. There's 3,468 of those, and that's 24.24% of all the bays. That's the largest percentage group. The 30 to 39.99 group are those hard to see tan ones, and there's 2,398 of those, and that's 16.76% of all the bays. It may look like some of those tan ones are in the yellow, but they're pretty much not in the yellow terrain color. These bright purple ones are the 20 to 29.99 meter above sea level bays. There's 1,175 of those, and that's 8.21% of all the bays in North Carolina. Still pretty much not on the yellows at this point. Now the darker purples are the 10 to 19.99 meters above sea level. There's 1,191 of those, and that's 8.32% of all the bays. So now the white is the bottom level. That's the sea level to 9.99 meters above. That's 366 bays. That's 2.56% of all the bays. So 2.56% of the bays basically are within 30 feet of the sea level. Those white ones would be the ones that would be underwater if we had a 10-meter rise in sea level. So if sea levels rose by 10 meters as shown here, basically we would lose 366 Carolina bays, or 2.56% of the population. One thing that you can, that I can really notice, just kind of commentary on this, is we have a really high density over here, and you're going to see the numbers. It's there's a lot of bays in this area and in these elevations, and even with the 30 feet, 32 feet or whatever it is of 10 meters of sea level rise, we still don't necessarily have a high density of bays in these yellow areas. And there are some, and it's pretty consistent density, but it's not the kind of density that you would see here. And so one thing that occurred to me is if these bays, if we did have a 10-meter current sea level, this is what things would look like. We would still see these bays along the coast and in some of these areas where would become the new shoreline. But doing my research, I found that there's actually been almost a 20-foot storm surges that have been recorded in North Carolina. So if we did have this current layout of sea level, and we had a big storm and it went up another 20 feet due to a storm surge, that would look like this and cover quite a bit of the yellow area terrain. So this is like a 52 foot. You can see down here, I don't know if I've been pointing that out. So this would be like 52 feet of sea level rise from current sea level, and that pretty much takes the yellow out of the picture. So perhaps if there was an ancient sea level 10 meters higher than we have today or thereabouts, and there were numerous storms, we would perhaps see erosion in those areas where we wouldn't see up here. So they might have started out more densely packed and become eroded. And that's why we see less density in those yellow areas. So there could have been more density here at the 10-meter increased sea level in these areas. But higher tides and or storm surges could have inundated those areas occasionally and wiped out some of the evidence. But that's just conjecture. However, there is kind of one interesting thing that kind of parallels this, that kind of washed out of the numbers. Let's take a closer look now at the data, summarized data from what we just looked at. So in here I have my elevation ranges and the counts and the percentages of the totals. That's all the stuff I verbally said. I also took the area of the bays that's given in the Avoid Basin spreadsheet, and I summed them up for each of these groups, and then I took the average bay size, which would be the total area divided by the number of bays, and did a couple more things. We'll talk about these last two last, but if you take a look, the one thing that's really interesting about this is the average bay size by elevation, and the average bay size goes from, at the 70 meters and up, it's about 11.68 hectares. When you come down to sea level, they're 135 averagely, and it's just a straight increase all the way. Depends how you look at it. From sea level up, the bays get smaller. From higher up to sea level, the bays get larger, and that's kind of interesting to see that. So when you look at everything, say below this one right here, 20 to 29.99 in elevation. So we have the average bay size is 42, 53, 135 as we go down. If we sum up these percentages of totals, this is about 19%. So about 19% of the bays, this is their distribution in size. And you'll notice the next one up, which has more bays, still have significant bays, is almost half of this one. So this group alone, which is basically 100 feet or 30 meters above sea level, are all much larger in size, relatively speaking, for their group. And then as we go up, they start to get smaller and smaller. So was the soil in these areas closer to the shoreline, was it just have characteristic that allowed larger bays? Was there some type of enlargement, erosion, or enlarging of bays in these areas due to inundation and or combination of soil type, and inundation meaning elevation? Perhaps we're going to find that the majority of the bays, I'll show you when we get to the soil portion, the majority of the bays kind of in this area right here, 24, 34, 40, 50 some percent or so, are in one soil type. And So let's take a look at that. So I find that interesting. There's some questions why we see the larger bays. Is it soil? Is it elevation? Uh, Combination of erosion, natural forces, natural enlargement. So this is that soil map provided by the state of North Carolina. It's nice because you can click on an area and you get the description, really complete description, formation, area, period, uh, discusses kind of with a detailed description, and it also gives the area of that shape, and that's actually in square meters. So basically what I did was I overlaid, let's get this situated, and we'll hide this. So I compiled each of these everywhere that I see Carolina bays in these soil types. I wrote that down. I'll close this. I'll show you where the Carolina bays are. Let's just start at above 30 meters. So, whoops. Uh, these are the one above 30 meters. So I'm just kind of breaking it out in elevation briefly here, just to kind of show again. We remember we had all the fingers. So this is basically above 100 feet or so. Here's all of the bays, and what we're going to notice is obviously this group right here has the most bays in it, and that's called the Black Creek Formation, and that has 6,654 bays located in it. The next formation is called the Middendorf Formation. That has 2,482 bays in it. The next formation is the Waccamaw Formation, and then this is the PD Formation, and this is the Yorktown Dublin Formation. So it overlaps. There's obviously more areas where there's bays, and there's even some fine little areas up here, which some are stone and rock, and so they were all counted, and I put them in a list. So here's the actual list that I made of all the different formations, and the name of the formation, the description, this ranking, which I will discuss, the areas of those formations. Now, this is not the area of the individual bays, this is the land area of the formation. The number of bays in that land area, this is a density, which is the number of bays per square kilometer. This number here is the total percentage of the bays. In other words, this 6,654 bays is 45% of all the bays in North Carolina. So just that one Black Creek Formation is 45%. And this 14.4% total percent of area means that of all these areas that contain bays, this Black Creek Formation is 14% of that. So once again, this Black Creek Formation is that area right there, and that has 46% of all the bays, and there's 6,654. So next we're going to look at the Middendorf, Waccamaw, PD, and Yorktown on the list. So here's the Middendorf. It has a total area of 5,300 square kilometers. There's 2,482 bays there. The density is 0.464, so it's quite a bit lower than this Black Creek Formation. It had 17% of the bays and 9% of the area. The next is the Waccamaw. Now that's really small. That's the 1,364 square kilometers. It's had 468 bays with a loading or a density of 0.343 bays per square kilometer. That's only 3% of all the bays and 2.3%, whoops, excuse me, of all the land. The PD Formation, which has 6,856 square kilometers of area, had 1,295 bays. So that's a density of relatively small even compared to these other ones of 0.189 bays per square kilometer. Had about 9% of all the bays and 11% of all the land. Then the Yorktown Formation uh, is really large in size, 16,738 square kilometers. But in that 16,000 square kilometers, there was only 2,615 bays. So this Middledorf is a third of the size and had almost as many bays. Super low loading rate or density 0.156. That's still about 20% of all the bays, and that's 28% of all the land. So that's interesting. And so the reason that we looked at the top five uh, specifically is because I took these descriptions, which I haven't read yet, and hopefully I'll give you a chance to read what they are. And I copied all of those descriptions into a program and asked AI to rank them from the highest clay content to the lowest clay content. And so this is how they were ranked. One being the highest clay content, and 14 being the lowest clay content, and that's felsic metavolcanic rock here. So is it right? I don't know. I don't know anything about the soils. The I know sand, so I'm sure there's sand in North Carolina. So totally, who knows if it's right or wrong. But what's interesting is that the top five ranked uh, clay-like soils has about 95% of all the bays in North Carolina in those soil types. So I think that's kind of interesting. But there's also the elevation component, because Middendorf and Black Creek Formation are the ones that are like 150 feet, 150 feet up. Uh, the Waccamaw actually has a little bit of elevation down there because even with the sea level rise, we saw that there would still be some of those barrier islands. Um, the PD Formation, which is, whoops, let me get that out of there. This formation right here, has a bunch of fingers coming out on it. Uh, Still not super high density. We get the same loading basically as the Comfort Member, as the River Bend Formation, as the Belgrade Formation. Uh, like I said, I'll let you see the chart with the numbers for all of them. Now, this is an interesting one. This is called, well, they're superficial deposits undivided is what they call it. And the numbers on those, on that one, is pretty interesting. And they call that sand, clay, gravel, peat, uh, uh, deposited in marine, fluvial, aeolian, and lacustrine environments. Um, Quaternary deposits not shown at altitudes greater than approximately 25 feet above sea level. So, in that group, which had 10,006 had an area of 10,616 square kilometers, there were 34 that we found, and most of those are not below 25 feet. In reality, they are on some of those little coastal little barrier islands or something at a little higher elevation. Look at that density, 0.003 bays per square kilometer, 10, 100. So you need 1,000 square kilometers for three. Yeah, that about pencils in. That's 0.2% of all the bays, but at 17% of the total land area that contains bays. And then as we scroll down, you can see that we get counts 34, 67, 161, 51, 39, 26, 20. Pretty low densities. The lowest is at surficial deposits, but that's a chart. Let me scroll through it here. So we're here at the Belgrade. Okay, pause. 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 I did also calculate averages for the eccentricities of all the bays in these ranges, and you can see that they're pretty much 0.69, 0.69, 0.69, very close. I don't, the there could be more significant than we think, that third digit, but probably not. But basically, if you look here at the little chart I have, 0.69 is basically a point 0.7. So they're very, very consistent between this shape. Definitely closer to this. That's the point 0.7. The rest are it's between these two. So that was also kind of an interesting distribution that averagely bays in all of these elevations kind of have the same eccentricity as at least given from the Ovade Basin sheet. So in summary, there's 14,309 Carolina bays in North Carolina. There's roughly 2,700 below 100 feet or 30 meters in elevation. And there's roughly 11,577 that are 100 feet or higher in elevation. There seems to be a trend where the average bay size becomes larger the closer we get to sea level elevation. We find that the most number of bays seems to be in the higher elevations and in the more clay-like material, where the top 5 sections or types of soil classifications is basically 94% of all of the bays.